Welcome back. All right, so moving on into more applications of our right triangle trigonometry, we can look at cofunctions. So let's define that real quick. So based on the complementary nature of trigonometric functions, so for example, sine and cosine, we know those two go together. Tangent and cotangent, those go together. Secant and cosecant will also go together. So we can call these pairs of functions cofunctions. Subsequently, cofunctions of complementary angles are equal. So let's just look at one specific case. So if we have a right triangle, and let's put our right angle there. Now, if we wanted to specifically put an angle in here for one of these angles, let's say that this angle was 40 degrees. If this angle was 40 degrees and this angle here would have to be the complement to that, correct? Because we already have 90, we have 40, and all three angles we should remember have to add up to 180. So that's going to force this last angle to be 50 degrees. So these two angles are complementary. But now let's look at the sines and cosines of those angles. So let's just put in some letters just to make it easier on us. We don't have to know what their sides are, we just have to look at their representation. So if this is our triangle now, and if we wanted the sine of 40 degrees, what do we notice about that? Well, the sine should be the opposite over the hypotenuse. So in this case, it's going to be equal to A over C. But what happens when you look at the cosine of its complement? So our complement is the 50 degrees, so the cosine is the adjacent over the hypotenuse. The adjacent now is side A. That's the side that's closest to it. And the hypotenuse is still C, so that is going to show that cofunction relationship. So those are going to be the same thing. And we could do that for all kinds of different combinations. So that's the idea behind this section. So we can generalize the process a little bit and come up with the following equalities. So we have the sine of 90 degrees minus theta should be equal to the cosine. Cosine of 90 minus theta degrees is equal to sine, and so on and so on. So we have all 6 of these identities, these cofunction identities. Now, to go even further, we've kind of hinted around some of these, but we haven't formalized them. So that's what we're going to do now. So the next ones are our reciprocal identities. So we've kind of talked about how there's those relationships. So sine and cosecant, those are reciprocals. Cosine and secant, tangent and cotangent, and so on. So we can have 6 different reciprocal identities. Furthermore, we can also see a relationship between tangent and sine and cosine. So sine over cosine will reduce down to the tangent of the angle. And cotangent is just the reciprocal, so we can reciprocate cosine over the sine. And last but not least, we have our Pythagorean identities. These ones are really nice when you're looking at right triangles as well. So the main one that you would want to try to commit to memory is the first one. Sine squared of theta plus cosine squared of theta is equal to 1. Now just to be a little bit careful about the notation, you can see the squares is in a weird spot here. It's between the sine and the angle. Don't let that freak you out. Just keep in mind that what it really means is this. The sine of the angle squared. It's just a way to write it without the parentheses is all. So if you said it like this, it would be equivalent. And that's the same idea for these ones down here. So, and these ones can easily be generated, these two but down below, can easily be generated from this first initial one. And the trick for it is to divide each of these by either sine squared of theta or cosine squared of theta. And that will get you these other variations. So, but in general, keep in mind the notation. When the squared is in between, it's the square of the whole thing, including the angle. So very important. Okay, so now let's try a couple of problems and see what we can do. So use the given function values and the trigonometric identities to find the exact value of each indicated trigonometric function. So if we got the sine of 60 degrees is equal to the square root of 3 over 2, cosine of 60 degrees is a half, what should be the sine of 30? So in this case, because it's 30 degrees is the complement to the angle that they're giving us. So which of these is going to be useful to finding the sine of 30? It's got to be the cofunction. So if we're talking about the sine of 30 here, we need the cosine of 60. It should be equivalent to that. So we now know sine of 30 should also be 1/2. All right, so for the cosine of 30, same idea. We need those cofunctions. So this should be equal to the sine of 60 degrees, which is square root of 3 over 2. Okay, those were nice little warm-ups. So what about the tangent now of 60 degrees? Well, now we're going to have to use our quotient identity because we know that this should be equal to the sine of 60 over the cosine of 60. And now just plug them in and simplify. So sine is the square root of 3 over 2. Cosine is a half. If you multiply the top and bottom by 2, that'll get rid of those fractions. So square root of 3 over 1, which is the square root of 3. And last but not least, cotangent of 60. Well, we know cotangent and tangent are reciprocal functions. So really all we have to do is flip this. Or we could use the quotient function, the quotient identity, and that will get us there as well. But it's probably going to be easier just to take the reciprocal of square root of 3. And so now we don't like square roots in the bottom. So let's multiply the top and bottom by the square root of 3, and we get square root of 3 over 3. All right, so that's a little bit of this. We're going to see some more using these identities in the next video. So see you in a minute.